I think it's started.
Okay.
It should be good.
I'm Lena, and this is Emily and Angelina, and we're investigating secondary succession in Point Pleasant Park in the aftermath of Hurricane Juan.
Okay. So some background information. Succession is referred to as the gradual change in a species of a given area with respect to change in the environment around it. There are two main types of succession, primary and secondary. Primary succession occurs when geological changes take place, causing changes to existing substrate or the creation of new substrate, whereas secondary involves disturbances that do not change, remove, or create new substrate. During succession, the abundance, diversity, and richness of a species in a given area are subsequent to change. The main type of forest you would see in Nova Scotia is the Acadian forest, which is comprised of birch, spruce, maple, beech, fir, pine, cedar, and hemlock trees. These forests are found across the eastern provinces of Canada and throughout some states in the US. Point Pleasant Park is an Acadian forest located in Halifax, Nova Scotia. This park will be the basis of our study as it is a great example of secondary succession in North America. On September 29, 2003, Hurricane Juan, a Category 2 hurricane, made landfall just south of Halifax. This storm caused massive amounts of damage, which most of the devastation occurring at Point Pleasant Park, where 70% of trees were lost. Point Pleasant Park holds a lot of importance to the Mi'kmaq Nation, as it was traditionally a gathering place known as the Place of Spirits. So some related studies. In 2016, there was a similar study conducted by Turchin over a shorter period of time. And there was also a study done by Burley in 2008 and a study conducted by Keyes in 2018. So with this study, we plan to answer the question, how have the overall forest community, density of dominant species, and species richness in Point Pleasant Park changed in the years following Hurricane Juan? For this question, we have generated 3 hypotheses. For the first set of hypotheses, the null hypothesis is that there will be no change in the overall forest community over time, and the alternative is that there will be an increase in the overall forest community in the years following the hurricane. For the second set of hypotheses, the null hypothesis is that there will be no change in density of the dominant species over time, and the alternative is that there will be an increase in the density of dominant species. And for the final set of hypotheses, the null hypothesis is that there will be no change in the species richness over time, and the alternative hypothesis is that there will be an increase in species richness.
So for the field and site description and rationale, before the destruction of Hurricane Juan, the park was an even-aged old-growth evergreen forest, meaning all the trees are about the same age. Point Pleasant Park soil is shallow in this area of Nova Scotia, which resulted in the uprooting of trees due to the lack of shallow root systems. And as of the procedure, Biology 2060 students collected data on the trees of Point Pleasant Park in one of the 6 study sites implemented in 2004, located at the south end of Halifax Peninsula, Nova Scotia, Canada. The park was thoroughly observed, and the study sites were located in the areas of highest hurricane impact on the forest structure. To conduct this experiment, the materials used was a measuring tape to the nearest millimeter with a margin of error of 1 millimeter. The 6 study sites are each 20 meters by 20 meters in size, and the data has been collected every year in the fall since the hurricane. Students have measured the tree density per species per site, as well as a tree size and diameter at breast height for each tree per site. Within these sites, all living trees greater than or equal to 2.5 centimeters in diameter at breast height were identified and measured. A tree is only considered a tree if it is larger than 2.5 centimeters. The density and species identity information were used to calculate species richness, diversity, and evenness. And from the data that we have collected over the past 20 years, we had to explore the relationship of total tree density, average tree size, and community metrics. To evaluate the changes associated with secondary succession in the park, we utilized information on species density and identity to perform calculations on species richness, diversity, and evenness at each site. We assessed our results, creating regression analysis scatter plot, graphs to represent our concluded data. This is because the sites don't depend on each other and they are not related to one another within the time period. And for the methods section, we also created a flow chart, and it basically helps us easily understand the methodology. Now, to review, the most affected sites were selected, which came to 6 different sites. The data collected was diameter at breast height on each tree per site, and this provides the average tree size, which helps to observe changes at the age of trees. And the other data collected was the tree density per species per site. From that, we can conclude density and species identity. Using that data, community metrics is now calculated. That includes species richness, evenness, and diversity. In conclusion, all of these factors allow us to explore secondary succession in Point Pleasant Park.
This graph shows the data collected in the years following Hurricane Juan using the Shannon Diversity Index. The Shannon Diversity Index is a way to measure the diversity of a species in a community, which is denoted as H. The higher the value of H, the higher the species diversity in a given community. This graph shows a linear regression analysis using the data that was collected from the same forest plots every year, with the exception of 2005, 2007, 2016, and 2020. The data shown here has an R-squared value of 0.3591. There is a positive correlation between species density over time. Therefore, this shows that the diversity does increase over time, which supports our alternative hypothesis that there will be an increase in the overall forest community over time. This data also follows the same trend as that found in Turchin's study done in 2016.
Density of dominant species over time. The 2 dominant tree species at Point Pleasant Park are the red spruce and the red maple. Linear regression analysis was used to determine whether there was a difference in the density of red spruce between 2004 and 2023. We found that there was an increase of an average of 5.25 red spruce per 400 meters squared from 2004 to 2023. There was also a weak positive relationship between red spruce density and year, showing that red spruce density has increased with time. Linear regression analysis was also used to determine whether there was a difference in the density of red maple between 2004 and 2023. There was an increase of an average of 35.5 red maples per 400 meters squared from 2004 to 2023. There was a weak positive relationship between red maple density and year, showing that red maple density has also increased with time. This continuous increase in the density of dominant species suggests that they will continue to increase until they plateau at their climax community level. Our findings suggest that natural regression of regeneration of red spruce and red maple is occurring after the negative effects of Hurricane Juan, which is consistent with findings of other researchers like Burley et al. 2008 and Keyes 2019.
So now we are observing species richness over time and the climax community. And the graph depicts a general increase in species richness from the years of 2004 to 2023, excluding the years mentioned before. The R-squared value of 0.64 suggests it is increasing with moderate or strong positive relationship between species richness and time. It is noted in the theses of Turchin that after a major disturbance such as Hurricane Juan, successional changes typically lead to an increased species richness. The main reason of that being that there's low competition. Additionally, removal of dead trees and the state of the seed blanket also impacts the richness. We can predict that as species richness increases after disturbance, it peaks and then declines as a climax community is approached. As the forest matures, competition for light, nutrients, and space increases, leading to a decrease in richness.
In conclusion, based on the similarities between our data and Keyes 2019, the Acadian forest in Point Pleasant Park is likely in early to mid-stage succession. The weak positive relationships between the dominant species density and the time, as seen with the R-squared values from figures 6 and 7, could be due to the presence of non-native species, as non-native species are often present in post-disturbance remnants of urban parks, and non-native species can prevent the establishment and growth of native plant species in post-disturbance communities. Because of the unique environmental conditions that come from being an urban park, species must adapt in order to survive and mature. These conditions could lead to the slow increase in the dominant species densities that we found. A Mi'kmaq teaching that could aid in the way we view and assist in Pleasant Park's recovery to a mature Acadian forest is the concept of netukulunk. Netukulunk emphasizes the interconnectedness of humans and the environment, and the importance of maintaining a respectful and reciprocal relationship with the environment. If we keep this idea in mind when looking at Point Pleasant Park's recovery, it could help shape our view of the park's recovery and help us determine whether we need to assist it or not. We would like to thank the past ecology students who have collected and prepared the data and graphs we've presented today, Alison and Shiori for helping us with any questions about the project, and the people who cleaned up the Point Pleasant Park after Hurricane Juan, allowing us to collect this data in the first place. Thank you. Also, I